This is part 4 of the series Three-Dimensional Solids, and I'm going to begin this part with a discussion of the lateral area of pyramids. And let's, as we have in the past with the different three-dimensional solids, I want to break this down into its different parts. So first, I want to talk about the vertex. Now, inasmuch as this has multiple vertices, the thing we call the vertex is the common vertex of all the lateral faces, or the intersection of all the lateral faces. So this would be the vertex of the pyramid. Then we have the lateral faces. These are, you'll notice, all triangular faces, and a lateral face is simply a face that has a vertex as the vertex of the pyramid. So these are the lateral faces. Notice that the base does not have as one of its vertices the vertex of the pyramid. So that distinguishes the base from the lateral faces. And of course, these edges are lateral edges, and that is a segment that is the intersection of any two lateral faces. So we have vertex, lateral faces, and edges so far. And then we have the base. And the base is a polygon that is adjacent to all of the lateral faces, no matter how many lateral faces it has. Now this polygon may be a regular polygon, or in this case, it's a rectangle. Now this is a base edge. These are all base edges. So the important thing to note here is that this base is going to be the determining factor in naming the pyramid. So this would be a rectangular pyramid, even though the lateral faces are all triangles. The base is a rectangle, therefore this is a rectangular pyramid. Now the next piece we're going to talk about is critical, especially for a rectangular pyramid like this, and that is something called the slant height. Now the slant height is a segment from the vertex perpendicular to a base edge along one of the lateral faces. So this is a slant height, this is a slant height. Now, the reason it is critical in a rectangular pyramid is you'll notice that this slant height is going to be a different length than this one. Because this base is not regular, this length is different than this length, then this length is going to be different than this. And that's going to be critical in finding our lateral areas and surface area of this object. We don't encounter these often, but when we do, it's very important to understand that. And the final element we want to look at is the actual height of the pyramid. Now you may think that since slant height has the word height in it, that this would be the height of the pyramid, but not so. The height is actually a segment from the vertex drawn straight down perpendicular to the bases. So you notice this segment is perpendicular in this direction and this direction. So this would be the height of the pyramid. Now I want to look at a couple of formulas that can be useful for finding lateral area and surface area of one of these pyramids, but I need to exercise extreme caution when I go through these formulas. The lateral area can be thought of as finding perimeter times slant height only if you're talking about a regular pyramid, because in this case, in our regular pyramid, you would have all bases of equal length, therefore the slant heights would all be equal. However, in a case like we have here, these slant heights are different, so this formula will not work. And so you must exercise great caution to understand that if you have a regular base, that is a polygon that's a regular polygon, all sides are equal in length and all angles are equal, that you can use this formula. I usually don't recommend memorizing a formula if you don't need to. The easiest way to do a lateral area for one of these guys is to find the area of that triangle, that is 1/2 base times this slant height, and multiply it by 2 because you have one here and one here. And then find the area of this triangle, that's 1/2 base times that slant height, and multiply it by 2 because you have one here and one in the back. Now that, I believe, is the safest way to find lateral area, but of course you're free to use any method you wish. Just exercise extreme caution when you're finding those lateral areas using the formula. All right, let's move on and look at an actual example. In this first example, we're being asked to find the lateral and surface area of a square pyramid. Now they give us that it's a square pyramid, therefore this is a regular base. And so I'm going to start off by calculating lateral area. So what I want to do is I'm going to start by calculating the area of one of these lateral faces, which is a triangle. So what we have then is, let's say lateral area is equal to 1/2 the base, which is 7, times the height. Now the height of this triangle is 11. That's the slant height of the triangle. Now the lateral area is going to be this dimension times 4. Because this is a regular polygon, I have 1, 2, 3, 4 of those faces. Again, you'll notice I didn't use the formula that we showed on the last slide, simply because I don't want to get into the habit of using that formula. I want to get into the habit of finding the area of these triangles and adding them together. It's the safest approach. So this is going to be our lateral area. Now once we find the lateral area, we're going to go ahead and store that in our calculator. I'm going to store that in the location L on my calculator. Now surface area then is simply going to be the lateral area plus big B. And big B is, remember, is the area of the base. Notice it's not 2 big B, simply because we only have one base. Therefore, that's all I need to do at this point is find big B. Now that's simply 7 times 7, or you could have said 7 squared, which is 49. And so surface area is going to be lateral area plus big B, which is 49. Now that's all we have to do is find this calculation, and this value is going to be 154, and that makes this guy 154 plus 49, which is 203. Well, that was a fairly basic example. Let's move on and take a look at a little bit more complicated example. In this problem, we're being asked to find the lateral and surface area of the regular pyramid. They're telling us this is a regular pyramid, therefore this is a regular hexagon. And we're faced with a little bit more difficult problem here, because that's all we're given is the radius of this regular base and the slant height. So in order to find any of the lateral faces, I'm going to need this length here. And the only way to do that, of course, is we're going to have to build our standard triangle. So that would be this triangle in here, and then we would want to build our apothem in here, and that will allow us, if we build this triangle and figure out what this slant height, this apothem is, given a radius of 6, then we should be in good shape. So I'm going to go ahead and draw that down here and get to work. Let's go ahead and make our triangle down here. Draw on the apothem. And we know our radius is 6. So, again, we're going to need our angle inside here. This is a hexagon, so 360 divided by 6 gives us 60 degrees for this central angle here. So that angle is 60 degrees. That makes this angle 30 degrees. So we have a 30, 60, 90 triangle. In the last unit, when we calculated regular polygon areas, we did a lot of double calculations. I'm not going to do that in this unit. I'm just going to assume you're going to pick the best method for you. I'm going to use 30, 60, 90 relationships whenever possible. 30, 60, 90, 45, 45, 90 relationships. They're just quicker. So I'm going to go ahead and label this side as X and this side as Y. And in a 30, 60, 90 triangle, this side is A, this side is 2A, and this side is A square roots of 3. We need this and this. Well, if 6 is 2A, then clearly A equals 3. So this value is 3 down here. That makes our overall base 6. So this distance from here to here is 6. And now I'll have enough information to calculate my lateral area. And we now have enough information to also go ahead and calculate the area of our base. Now that we have our background information taken care of, let's go ahead and start with our formulas. We have surface area is equal to lateral area plus area of the base. And we know that lateral area is going to be 1/2 base. The base is this 6. That's what we calculated here, this 6. So 1/2 6 times slant height. Now that gives us the area of one of our lateral faces. And since we have 6 sides, we multiply that number by 6. That gives us our lateral area. And then we add to that the area of our base. And our base is a regular polygon. So that area is 1/2 pa, 1/2 perimeter times apothem, which is 1/2. The perimeter is 6 times 6 sides. So perimeter is 6 times 6 sides. So that was the base and 6 of them. And times our apothem. And our apothem is A square roots of 3. A is 3. So this would be 3 square roots of 3. That would be the length of our apothem here. A for 3 times the square root of 3. Now that's all we have to do is plug these into our calculator and we have our values. So our lateral area then is going to be 216 plus our area of the base, and this comes out to approximately 216 plus 93.5, which gives us approximately 309.5. We're approaching the end of our time for this part. I have another example I'd like to work, but I'm going to do that at the beginning of the next part, so I will talk to you in the next video.